Alright, so in our next section we're going to start to go through word problems. And so with word problems we're going to develop these tables to go through. And so I've got a couple here to practice. And we'll just start off with the first one and just kind of move our way through. So in example 6 it says Stella takes 4 hours to paint a room and it takes Josie 3 hours to paint the same area. How long will it take them to paint the room if they work together? So you can see we have time to paint the room, the fraction of the work that gets done in 1 hour, and then the fraction of the work that gets done in X hours, however long it takes them to finish. So, for instance, for Stella, it takes her 4 hours to paint a room, so that means that she can get 1/4 of the work done in 1 hour. The fraction of the work that gets done then in X hours would just be X over 4. If it was 2 hours or 3 hours, it just keeps changing the number on the top. So, the fraction of the work done in an undetermined amount of hours is X over 4. With Josie, we can do the same thing. It takes her 3 hours to paint a room. She can get 1/3 of the work done in 1 hour, which really just tells us she can get X over 3 work done in X hours. So if they work together, the time to paint the room is what we're trying to solve for. X, we don't know. But the fraction of the work that they can get done in 1 hour ends up being combined, right? 1 over however long it takes them to paint the room. So then, if we start to take a look and combine these, really then we have kind of X over X, right? We have the amount of work to get done that we don't know over the time it takes to paint the room. So X over X is just 1. So here we have a relationship. We have this idea of an expression that kind of says the time it takes Stella to paint the room in an undetermined amount of hours plus the time it takes Josie to paint the room is equal to 1, is equal to them painting the room and getting it done. So from here, we can solve for X and find out how long it takes them to paint the room. So I'm going to multiply by 4 everywhere. 4 and 4 cancel out. X plus 4x over 3 is equal to 4. I'm going to multiply by 3 everywhere. And I can see the 3's cancel. So 3x plus 4x is equal to 12. 3x and 4x make 7x is equal to 12. And then I can see that x is equal to 12 over 7. So how long does it take them to paint the room? It takes them a full hour, and then there's 5/7 left over. So 1 5/7 of an hour. Or, if I wanted to put it as a decimal, I could say that x is equal to, let's punch this in, 5 divided by 7 gives us 0.714. So 1.714 hours. And if I wanted to know how many minutes that was, just out of curiosity, that basically, just another way to say the answer is basically to say it takes about an hour and 42 minutes to paint the room. Okay, give or take. So, just as an idea on how we can use these tables to set up these word problems. So, I've got another one over here. Where now our table is blank, so we got to try to fill it in. We'll work this one out together as well. So, in a dog race from the Pas to Flin Flon, Manitoba, the total distance was 140 miles. So, conditions were excellent on the way to Flin Flon. However, bad weather caused the winner's average speed to decrease by 6 miles an hour on the return trip. So the total time for the trip was 8.5 hours. What was the winning dog's team's average speed on the way to Flin Flon? So it's looking for average speed on the way to Flin Flon. Right, so Flin Flon, the trip to, is really the trip to Flin Flon. The return trip is going to the Pas, the returning back. And so it says that the total distance covered was 140 miles. Okay, so 140 miles is the total distance covered. That means that each one of these would be 70, right? 70 down, 70 back. Conditions were excellent on the way, so we assume they're traveling at an average speed on the way to Flim Flon. So we need to let our average speed, okay, so let average speed equal x. Now it says that on the way back, the weather was bad, and so they had to decrease their speed by 6 miles per hour on the return trip. And then the total trip was 8.5 hours. Okay, now 8.5 hours, we could leave it as a decimal, or we could also call this 17 over 2, okay, as a fraction. So now, if we knew what our times were, we could kind of develop this expression here. And so there's an equation used with physics that can calculate using constant speed that starts to talk about a relationship between distance, speed, and time. So if you think about speed, speed's normally measured in something like miles per hour or kilometers per hour, meters per second. It's a distance per a time. So speed, which we normally represent as v, can be represented as v is equal to d over t. A quick formula rearrangement with this would tell us that the time is really equal to the distance over the velocity. And so you kind of have to have that general understanding in order to be able to solve a question like this one. But something like this is something that normally is kind of given out to you as an idea on how to solve. So t is equal to d over v. Okay, so the time there, distance over speed. Well, that would be 70 over x. Distance over speed. Okay, that would be 70 over x minus 6. Now I have this relationship where we know what the total time is, I know how long it took to get there, and how long it took to come back as an expression of the average speed, as an expression of x. So now I can set up this relationship, 70 over x plus 70 over x minus 6 is equal to 17 over 2. Now we've worked on problems like these from before. So my next step now is that I'm going to take this and I'm going to multiply by x because I want to be able to cancel these out. So multiply by x, multiply by x, multiply by x. That's going to help cancel out those two terms. And then I'm going to write what I have left over. So I've got a 70 plus a 70x over x minus 6 is equal to 17x over 2. Now I'm going to just move to my next term. My next term in this case is x minus 6, so I'm going to multiply by x minus 6 everywhere now. X minus 6 and x minus 6. That cancels these two terms out. And then again, I'm going to rewrite out what I have left. So it looks like now I have 70 x minus 6 plus 70x is equal to 17x times x minus 6 all over 2. And then my last part is to just multiply by 2 everywhere. We'll just pick our different color here. So multiply by 2 everywhere times 2 times 2 and times 2. The 2's are going to cancel here, top and bottom. And then I'm going to write again what I have left over. So here I've got 140 x minus 6 plus 70 times 2 gives me 140x equals 17x and then x minus 6. So it looks like I've got some fairly large numbers here to try to work with. So what we need to start to do now is we need to start to simplify this out. So in my next line, I've got 140x minus and then 140 times 6 gives me 840. And you definitely need a calculator for this part, no doubt about that. plus 140x is equal to 17x times x is 17x squared. 17 times negative 6, or 17x times negative 6, gives me negative 102x. So now I need to put everything on the same side. Looks like the 17 is positive over on the right side, so I'm going to move everything there. I do have 140x and 140x, so I have that twice, so I'm just going to combine those together before I move it over. 280x minus 840 is equal to 17x squared minus 102x. And so now I'm going to combine everything over on the other side. So I'm going to subtract a 280 on this side. I'm going to add an 840, which means I'm going to be subtracting a 280x, and I'm going to be adding an 840. So these are going to cancel. I can see I'm going to have 0 left over. So 0 equals 17x squared minus 382x plus 840. This is a hard trinomial like we've never done before, because all of our hard trinomials up to this point we've dealt with relatively small numbers and have been able to work with them. Luckily, we have a system or a formula that we can use where we can solve any quadratic equation, and maybe if you think about it, you'll be able to kind of come up with what that is that allows us to solve for any quadratic equation. And in this case, I'm talking about the quadratic formula. So we have our A term, our B term, and our C term. Let's do the quadratic and see what this gives us. It's a much more direct way than trying trial and error to do a type 2 trinomial kind of question. So the quadratic equation, if you can't quite remember what it is x is equal to negative b plus or minus the square root of b squared minus 4ac, and that's all over 2a. Or x is equal to negative times a negative 382 plus or minus b squared is negative 382 all squared minus 4 times a times 17 minus c, which is 840, all over top of 2 times 17. So x is equal to, a negative times a negative is a positive, 382, plus or minus. If I take the 382 and square it, I'm going to get a huge number. So under the square root here, I'm going to get 145,924 minus 4 times 17 times 840. That gives me 57,120 all over 34. 2 times 17. X is equal to 382 plus or minus 145,924 minus 57,120 gives me 88,804. So 88,804 all over top of 34. We're starting to work our way down now out of this thing. X is equal to 382 plus or minus, and if I take the square root of this, this is where I kind of get that sigh of relief that it works out okay. Perfect square of 298 all over 34. So now if I take a look at the positive root from this, x is equal to 680 over 34. And if I take 680 and divide it by 34, I get a nice answer of 20. If I take a look at my negative root, then I end up getting x is equal to 84 over 34. And 84 over 34 does reduce down into 42 over 17, which I can't do anything else with. As a mixed fraction, this thing would work out to be 2 and 8/17. But what I do know out of this is that if I pick this as an answer, if I go way back up here to see how it's x minus 6, that would mean the return trip would actually be going negative speed, and that doesn't make sense in the problem. So, like before, this is an extraneous root. And so, what we can do after that is we could take 20, and we can plug 20 into our equation to verify that we do get a solution out of this, and in this case, it works out. So, those are two different word problems that kind of help us figure out how to go through word problems in general and solve for them. I do have one more to run through, example 8. And so in this case, we have a train that's scheduled to kind of, let's say a train is a scheduled run of 160 kilometers between two cities in Saskatchewan. And so if the average train's decreased by 16 kilometers an hour, then the run takes a half hour longer. And then it's asking what's the average speed of the train. So we have distance, speed, and time. Notice that it's looking for a total in this case. So we need to come up with our formula. So maybe what I'll get you to do is to pause the video, try it yourself, see if you can fill in the table and come up with an equation, and come back when you're ready. Alright, so some prior knowledge from the last question. Remember, we had taken a look at distance, speed, and time, and we had determined that speed was equal to distance over time, which then also meant that time was equal to distance over speed through a little formula rearrangement. So if I were to fill in what I have here now, the train is a scheduled run of 160 kilometers between two cities, so its total distance traveled is 160 kilometers. If the average speed is decreased by 16 kilometers, then it's going to take a half hour longer than normal. So we have kind of two separate parts here. It's asking for average speed, so we need to let average speed equal x to figure this out. So normally we'd have this set equation here where if it was an average speed problem, we could say, okay, it's traveling at average speed. It's going to arrive there at 160 over x, right? This is normally what would happen. But our problem has changed in that now it's saying that if the average speed's decreased by 16 kilometers, okay, it's being decreased by 16 kilometers, it's going to take an extra half hour. So it's going to take that 160 over x plus an extra half hour longer. Because remember, this 160 over x, that's the time that it would normally take to get there. We're going to add on a half hour if we decrease by 16. So I have two separate kind of scenarios here on what should happen and what could happen out of this using our equation for time that we had over here. So we had, if everything was traveling regular, I'd have 160 over x, but I know that it's going to take me an extra half hour to get there. And it's going to take me an extra half hour to get there if I'm traveling the same 160 at a decreased speed of 16 kilometers per hour. So using this idea, I now have an equation that I can work with, the same from before. And the hard part out of this is making the equation. If you can kind of read through the idea and get the logic of it to make the equation, the rest of it actually isn't too bad because it's things that we've done already. So understanding that it's going to take an extra half hour on top of the regular time if the speed is decreased by 16. This is an equation for time, and this is an equation for time. It's just this equation for time has this decrease in speed, which indicates that it's going to take that extra half hour. So I'm going to start to solve for x from here. We're going to multiply by x to start on each one, so multiply by x. The x's cancel, and I'm left with 160 plus x over 2 is equal to 160x over x minus 16. In my next part, I'm going to do the opposite again here. We're going to say x minus 16 for each one, x minus 16, and x minus 16. The x minus 16s cancel. I've got 160 times x minus 16, okay, right here, plus x times x minus 16 is equal to 160x. Now my last step is to get rid of the 2 that's on the bottom here. So I'm going to multiply by 2, multiply by 2, multiply by 2. They're going to cancel, and then I'm going to have 320 x minus 16 plus x minus 16 is equal to 320x. Now I need to expand this out and start to solve. So 320x, multiply those two. 320 times 16 gives me 5,120, so 5,120 plus x times x is x squared minus 16x is equal to 320x. Now my next part, I need to start to combine my like terms together. So I have an x squared on this side, a 320x over there, so I'm just going to start to combine my like terms together. So x squared comes first, plus 320x. I'm now going to subtract the 320x over to the other side. So subtract 320x minus 16x minus 5,120 equals 0. I had an x term here, x term there I moved over, my last x term right here, and then the minus 5,120. Combining all of those x terms together, it looks like I'm going to get negative 16x because these two are going to cancel out. So minus 16x minus 5,120 equals 0. This one is actually a type 1 trinomial. We could use the quadratic equation again. Or you could try to think and see if you could figure out maybe with a calculator what two things can multiply to give 5,120 and add to give negative 16. So I did go through and just kind of punch in some numbers and try to figure out what this would be instead of doing the quadratic. And it works out that it actually didn't take too long once I realized that it went into 2, 4, 8, and 16 and all that kind of thing. So I ended up getting values that were x minus 80 and x plus 64. So it was 80 times 64 that gives 5,120. That means in this case that x is equal to 80 and x is equal to negative 64. In the context of the question, that negative 64 would be considered to be an extraneous root. And so we only have one root that's really left over. That's our answer. And so the average speed of the train was 80 kilometers per hour. So we've covered a lot of different topics here on rational equations and solving rational expressions, and so you'll have a little bit of time to kind of practice some problems leading into the next little bit. So if you have any questions, let me know, and good luck.